Hey, I want to talk a little bit about balanced forces and something that can be a little bit tricky about that, balanced forces, and tension. With some forces, it's pretty easy to see when forces add up. Let's say we have two different people here, two people, and they're each pushing with, say, I don't know, 100 pounds of force on the back of that car. We can see pretty easily. I'm going to leave out the up and down forces right now. We would have 2 normal forces, one on the car from person 1, on the car from person 2, going that way. If I'm looking at frictional forces, and I wanted to account for each tire individually, I could say I got 1, 2, 3, 4 tires, each of those with friction. 1, 2, 3, 4. And if this thing was wasn't moving at all, or perhaps moving at a constant velocity, it would be balanced. Let's say 4x, our frictional force on the on the car from the road, from each of the tires there. Okay, they had 200 pounds total here. We would need 200 pounds of friction to balance that out. Gets a little trickier when we're talking about tension. Let's say I'm trying to lift this heavy weight, and I've got some type of a pulley system available here. Okay. Hey, so let's say our block weighs 300 pounds. Well, could I possibly lift that? And we're taking a look at that, and we would end up saying gravity here. But take a look at this. I have tension from this block to here, and also to here. I have 2 things of tension. When I end up going through and circling my the weight and block here, I see I have 1 gravity down, force of gravity on the block from the earth. But what's holding up? We have 2 tensions. 2 tensions. As if this weighs 300 pounds, then the tension, the force of tension from each of these ropes, which is actually the same rope, that's the tricky part, from this one rope is 150 pounds for one side of it, 150 pounds, let me write that a little better, 150 pounds for the other strand, but it's the same rope. And that's the interesting thing about ropes, is that they have the same tension throughout. So to lift this 300-pound block, how much do I have to pull on this this rope? Only 150 pounds. It may seem like those forces are not balanced, but remember this, 150 pounds is applied every time the rope runs between the ceiling and pulley up here and our weight. Let's take a look at a little different, slightly different example. Okay, so what I've drawn here is I have, I'm going to call it 80 newtons, an 80 Newton block here held up by a cable that runs over a frictionless pulley, over another frictionless pulley, and down to another 80 Newton block. Okay, put the N on there. All right. Hey, so let's go ahead. We'll say that these are at rest. They could be moving at a constant velocity, but for this, we're going to say that they're at rest. Let's go ahead and draw interaction diagram for this. My non-contact force. I've got gravity. The only force that's acting on this is the contact force of tension. Let's go ahead and enclose this. I only have 2 forces acting on it, gravity down, tension up. I have a force of gravity on the block from the earth. I know that's 80 newtons. The tension must also be on the block from the, I'm going to call it the rope, must also be 80 newtons. Hey, if we went over on this side, I think you could pretty easily see that we also have a tension of 80 newtons, because it has to hold it up. How about the tension right here? You might think that it's 160 newtons, because we got 80 newtons from this side, 80 newtons from this side. But something about ropes is that their tension is uniform throughout. So even if I ended up saying, hey, I'm going to go right here, I have 80 newtons pulling that direction, I have 80 newtons pulling at that direction. That's still 80 newtons of tension all the way throughout this entire cable. Okay, so let's consider this final example. I have a block, fairly massive. It has a weight of 600 newtons, and I have it set up on a pulley arrangement. And I can see that the cable goes back and forth 1, 2, 3, 4, 5, 6 times back and forth between these two. If I were to enclose this, I would see I have 1 force of gravity down, and I have 6 tensions up. What would the tension be at the end of this rope to be able to hold this up? Consider how you'd address this, and then in addition to your notes, go ahead and answer this in your discussion. So go ahead and put it in the discussion.